We're recording right now. Just letting you know. Okay, so everybody has their volume 2, correct?
Yes.
Okay, now we do. Volume 1, leave it home. All right, we've covered everything in volume 1. We are going to start, however, with the handout you got at the start of class. And we're going to be looking at likelihood and probability. The top of your handout looks just like the screen. And if you notice, the very first thing that you have is your vocabulary. You have to know your terms. Like when we did statistics, I told you guys, study the terms. You'll be tested on them. If you don't know these terms, there are going to be some questions you cannot answer. And that's going to really hinder you on some of these problems. First off, we're studying probability. Simply put, probability is the chances of something happening. Okay? And we're going to look at it fairly basically. Outcomes are all the results that could happen. If you flip a coin, what are the 2 results? We're going to stick 2. Don't give me the what if on that 0.5% of it happening. But what are the 2 possible outcomes of flipping a coin, Hank? Heads or tails. Okay, those are the outcomes. The event would be the specific thing that I want to happen. What's the chance of it landing on heads? 50%. Chance of it landing on tails? 50%. We're not getting into the whole science of one is slightly heavier than the other, okay? We get that argument every class period.
How would that even happen?
We're going to bypass it, the way it's molded.
Oh, molded?
With the way they press the coins.
Like
So, we're doing theoretically, there's 2 possible outcomes. It could land on heads, it could land on tails. Okay? So, based on that, the 2 possible outcomes, each of them has a 50% chance of happening. Okay? It could land on heads or it could land on tails. Simple enough? If I roll dice in a game, that's plural. What is singular? Die. Okay. So I'm not telling anybody to go die or anything. When we talk about a die, we're talking about 1 in the set of your dice. Okay? What's the probability, the chance that you're going to roll that dice and it's going to land on a 4?
20.
Hank?
20. No, sorry.
1 out of 6. There's 6 sides to your dice, right?
I was thinking of 4 sides.
No, dice are going to have 6. It's a cube. But that's what we're talking about with probability. The next terms that you have on here, impossible, unlikely, equally likely, likely, and certain. These terms are used to describe likelihood. And we're going to focus on these with the probability scale. When I ask you for probability, and I made the last class note this, it'd be a good idea to note this as well. If I ask you for the probability, I want a number. Okay? 50%, 1/2, 1 out of 6. If I ask you for the likelihood, I'm asking you for words. Okay. Is it impossible? Is it unlikely? Is it certain? And I know in a lot of things we try to avoid terms like impossible. We're always told nothing is impossible. Okay? It's going to be very obvious in this that something is impossible. If I gave you a bag of pennies, What's the chance that you're going to reach in and pull out a quarter?
Not much. Wait, you can't because there's no quarters.
There you go. If it is a bag full of pennies, you cannot reach in and magically pull out a quarter because it does not exist in that bag. That would be classified as impossible. Okay? It simply does not exist. If I hand you that same bag of pennies and I say, what's the chance you're going to pull out a penny?
1,000. 100%.
That's 100% guaranteed because that's the only thing that can happen. Okay? So when we talk about something being impossible versus something being certain, it's going to be a very obvious thing. Nothing else can happen, or it's the only thing that can happen. All right? Equally likely is the middle part. That's your coin flip. You only have one of two options. It's a 50-50 chance there. But then you have the span between it. And what I mean by that is between the 0 and the 1/2, this entire section is considered unlikely. From 1% to 49.999% is unlikely. So we're just going to mark up our scale a little bit. You got 0. That's impossible. You have your 1/2. That's our 50-50. Anything between them is considered unlikely. You look at the weather forecast, it's a 15% chance of rain. Unlikely. It's a 40% chance of rain. Unlikely. Okay? You're going to roll the dice for your game, and the chance of rolling a 6, unlikely, because it's only a 1 out of 6. Okay? Then you have the other side of 1/2, all the way up to something being certain and guaranteed. And that entire side is likely. Everything above 1/2, all the way to 100% guaranteed, is likely. 70% chance of rain, you should probably bring an umbrella. Okay. 85% chance of snow. In Mississippi, we buy out all the bread and milk in the store. Okay. But that's where those range from. Okay? We good so far? Any questions up to here?
So what percent would be considered likely?
Let me go to the next slide. It might help you with one. Here's 2 more probability scales. I like these because that bottom one's got just a little bit of extra more detail with the percentages. You're impossible, everything's a 0. You're not going to go to the cafeteria and there's going to be a T-Rex standing there, serving you lunch. Okay? You can keep all your feelings about the lunch ladies to yourselves, but, there's not going to be a legit velociraptor serving potatoes. Okay? That's impossible. 0, 0, 0. Okay? And then you have the other side at a 1. It's certain. If I put everybody in this room, I put your name on the wheel and I spin the wheel, I am certain to land on somebody in this room. No what ifs. Let's just keep it simple. That's a 1, 1.0, 100%. Okay? And then that middle. Okay? 50-50, you can think coin, 50-50. Somebody's having a baby. It's going to be a boy or a girl. All right? There's your 2 options here, folks. Okay? 50%, 50%. You only have 2 choices. Okay? So there's your 1/2, which is the 0.5, which is your 50%. They all line up. Those are the only 3 that are exact, only specific numbers. Likely and unlikely is anything in the middle. We good? All right. Let's look at the 2 questions below there. We want to use the probability scale to describe these. What does it mean for an event to have a probability of 1/2? Hank.
It means 50% or like equally.
Okay. It's 50%. It's equally likely. We could also say there's an even chance. Equally likely to occur as to not occur. But either way, the words equal or even are going to be in there. What does it mean on the next one if an event has the probability of 1/4? Fisher?
25% unlikely.
Okay. We could specify it to 25%. Or we could say that it is unlikely to occur. So 25% are unlikely. Which of these would be the likelihood of the event? Hank?
The likelihood would be the unlikely and equally likely.
Yeah, the words are going to be your likelihood. The 50%, the 25%, those are your probabilities. Good. Bottom of there, you got 3 spinners. Spinner A, spinner B, spinner C. On which spinner is the green likely to win, unlikely to win, and equally likely to win? Let me give you about, I don't know, 35 seconds. I think your groups can handle it. I'll even pause your video for you. Okay, spinner A. Remember, we're focusing in on the green section to win. How would we classify spinner A about green's likelihood to win, Ellery's?
Equally?
That is equally likely. Why did you say that it is equally likely?
Because it's equal.
Meaning what?
Like it's split in half.
Yeah. You have half a chance of getting red, half a chance of getting green. It's a 50-50 chance here. Okay, spinner B, Sadie?
Unlikely.
Why is it likely to win with green?
Because like green is a lot more than red, and red's just like a little space.
Visually, we can see that green takes up a lot more of the spinner. All right, Fisher, what about spinner C?
Unlikely because there's less green than red.
Good, there's less green than red. So visually, I mean, we don't even need numbers when we're talking about a lot of the likelihood. We can see that. But a question about these spinners, and this is going to bring us into something else. Which of these spinners would you consider to be fair? Every person in this room should be so well acquainted with things being fair. It's the argument ever since you guys were like 2. It's not fair. Eleanor. Okay, spinner A is considered to be fair. Why is spinner A considered to be fair? She says because it's half and half. Okay, does something have to be half and half, that 50-50, in order to be fair?
Not really. They just have to have an equal amount.
She nailed it. For something to be fair, it does not have to be 50-50. Okay? Things just have to be equal. I can take a completely different spinner here. I can divide it into 4 equal sections. I can have them each with a different number, and that can be considered fair. Because they all have what chance of occurring? What's the chance of each of these numbers occurring? 25%. But is that an even chance? Is that equally likely on the probability scale? No, it's not. Equally likely on the probability scale is 50%. These are each 25%. It's just fair. Simple as that. We don't like to admit it, but the wheel that we spin with our names technically is fair. All the pieces are the same size and everybody's name is up there once. That makes it fair. Okay? We all have the same chance of getting called on. But the chance of you getting called on is actually unlikely because you are just 1 out of 27 names. Okay? So we need to be careful when we talk about that 50-50 chance and when we talk about something being fair. Okay? Fair, everything's just evenly divided. Everything's got the same opportunity. Okay? All right, back side of that page. I'm going to give you in your groups about 2 minutes. I want you to tell me where these would fall on the probability scale. You can give me a probability, you can give me a likelihood. Common sense here, folks. Okay?
Could we do like impossible?
Yes, you can tell me the word of likelihood, or you can give me a an actual probability number. But I'll pause and let y'all chat. Okay, let's take a look at these, and I know Anderson is preparing his arguments.
No, I'm not gonna do it. I'm just doing it.
Oh, that's okay. I'm prepared to refute the arguments that I've been listening to from around the room on some of these. Let's do ones that we're not going to argue at the moment. Let's look at E. A red cube will be drawn when a cube is selected from a bag that has 5 blue cubes and 5 red cubes. What's the chance there? What are the size of the cubes? The size doesn't matter. It's equally distributed. You got 5 red, 5 blue. Ayla? It is possible, but it's even more specific than just possible. Hank? 20%. It's not 20%. You've got 5 red and 5 blue.
Oh, wait, sorry, I meant 50.
It's 50% on that one.
No, I meant
50% is what? Equally likely. All right. D, a spinner with 4 equal parts numbered 1 through 4 will land on the 4 on the next spin. But at some point it has to stop. So what's the probability or the likelihood that it's going to land specifically on the 4? It is unlikely. All right. A round disc with one side red and the other side yellow is going to land yellow side up when flipped. That's 50%. That is equally likely. All right, Anderson said he was not arguing the dinosaur question. So what's the chance that you're going to be going home today and there's going to be a live dinosaur, a velociraptor, a T-Rex, a brontosaurus?
Equally likely.
Okay, we know that this one is impossible. Okay, I save B and F just for the sake of arguing. Shh. All right, B. A solid rock dropped in the water will sink. So we take a solid rock, it's going to sink in the water. Okay, Anderson.
100%.
It is 100%.
No.
Alex wants to argue it.
No.
What?
How dense is the rock? How dense is the water?
Bro.
Okay.
Not enough information.
It's not enough information. Okay, now I will tell you, I did look it up. All right, just because somebody's always going to argue. I did look up the Dead Sea. It says a typical solid rock will not float in the Dead Sea. The density of the Dead Sea may be able to hold a human to float, but it is not dense enough to hold the rock up.
Yeah, rocks.
But it can't hold Dwayne Johnson, so like.
How can it hold a person but not a rock?
Rocks are more dense in their making.
They're heavier than us.
Yeah.
For real?
And then I also did check. There is a rock that does float on water. It is pumice. It's volcanic. But it can only float on water for a certain amount of time before it becomes waterlogged and sinks. So it is 100% that the rock will sink. All right. Now we come to number 7. That tomorrow the temperature outside will be negative 250 degrees. Anderson brought up, what degree are we talking about? So Anderson, here's some specifics for you. All right, first of all, negative 250 degrees Fahrenheit. There is no recorded temperature whatsoever that we have documented that the Earth has ever been negative 250 degrees. Okay? Now, if it was negative 250 degrees Celsius, that would convert to negative 418 degrees Fahrenheit. If it was negative 250 degrees on the Kelvin scale, that would classify as negative 909.67 degrees Fahrenheit. So, Fisher.
It's unlikely, actually. Yes. It's unlikely because what if the sun boomed? Yeah, what if the sun...
Then, if the sun was gone, the entire world would cease to exist.
Yeah, so that would be like negative.
Wait, can it not be? If it's not, can it be?
What if you're on Neptune? No, what if you in gas? That says outside.
It said outside, here, on our planet. Noah?
What if we just drift millions of miles away from the sun and we all die?
We all die. Oh, God.
Is it cold in galaxies?
Isn't like Neptune like in the negative south?
Y'all are crazy. Okay, yes, we are classifying this based on Earth temperatures.
At nighttime in Antarctica.
It did not specify that we're on Earth. Oh, this will be a fun group. I brought up the evidence. And if the Earth was just slightly away from the sun or slightly towards the sun, it would either freeze or burn up. I mean, that's been scientifically proven.
Can you Google how cold it's ever been in Antarctica at night?
Wait.
Okay.
It's like the coldest temperature ever.
All right, let's see.
Yeah, what is the coldest temperature?
Coldest recorded temperature. The coldest recorded temperature on Earth is negative 128.6 degrees Fahrenheit in Antarctica on July 21st, 1983.
That's the day after my birthday. What was that, the year?
In July. So to say negative 250 is nearly twice as cold as that.
The polar bears.
All right, crazies.
They not die.
All right, last question, Fisher.
No, it's crazy.
Or statement.
Wait, is that why they're endangered?
It's a crazy one.
It's a crazy one. Bring it on.
Okay, so what if we brought the ISS into Uranus?
It would probably break under the pressure of gravity.
You're right.
Haha. See, now I'm glad Daniel's in class. He's back in class now. It would break under the pressure of gravity. Daniel, thank you for bringing your logic in here. We're gonna need Daniel this lesson with some of y'all. Okay. This handout, do me a favor. Do not lose this handout. We're either using it tomorrow or Friday. I can't remember which one I've got it scheduled for. You'll have to make up class. All right. I do want you to get your book out. Go to page 509. So, hey, fold the handout up and stick it at page 512. You just got to be able to find it. 509. I'm going to give you about 30 seconds.
You couldn't stand still for like 25 seconds. Yeah. Highest higher someone.
So we do this paper thing, and then we do the definitions of like okay if I steal your pencil?
Yeah, go for it. Okay, page 509. We're going to look at a couple try-its. There's one right in the middle. And they say they've given you a game piece that has 12 sides, and it's labeled 1 to 12. I've got lots and lots of visual people. You don't do well unless you see it. Okay, who are my visual people? Trust me, I know you know who you are. In probability, because a lot of the things that we're going to be looking at are three-dimensional, like this dice, right, or this die game piece thingy, if you know that it's numbered 1 to 12, list your numbers out 1 to 12, okay, so that you can see what you're talking about and you can manipulate what you're using, okay? So on this particular question, we've got our dice. It's a great Dungeons and Dragons piece here. 8, 9, 10, 11. Oh, it's a game. Okay, so 1 through 12, I've got it listed on the board so we can physically see what we're dealing with. It has 12 sides. It's 1 through 12. So is this a fair game piece? Theoretically, yes. Everything's up there once. All right. On A, it's asking for the probability of rolling an 11. Notice how I wrote it in blue. Capital P stands for probability. And then inside the parentheses is the event that I'm wanting to see. So if I go through this, I need to know how many 11s I have. So I'm going to go through and mark my 11s. Well, how many did I mark? 1 out of 12. That's my fraction. There's my probability, 1 out of 12. Probability isn't just a fraction, though. What is it as a decimal? Say that one more time. Who just said a decimal? Because I think it may have been off just a little bit. Izzy?
0.083 repeated.
Okay, 0.083 and the 3 repeats. Okay, so probability can be a fraction. It can be a decimal. It can be a percent. What would this be as a percent? 8% or 8.3 repeated percent. What is the likelihood of rolling the 11? The likelihood. I don't want a number now. Now I want a word. Go back to that scale. Daniel.
Unlikely.
It is unlikely to occur. Okay. We go to B. I want the probability of rolling a number greater than 5. So I'm going to clear out my markings up here. And I want to identify my numbers that are greater than 5. Which numbers are bigger than 5? Hank?
6, 7, 8, 9, 10, 11.
Okay, 6 through 12 are greater than 5. How many numbers did we identify? 7 out of, there's our fraction. So 7 out of 12. So let's turn this into a decimal and a percent. What is 7/12 as a decimal? Good. 0.583 repeated. 0.583 repeated. 583 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 What is the percentage? Fisher.
58.3 repeated percent.
Good. 58.3 repeated percent. And then the likelihood. The likelihood of it occurring. Eloise?
Oh no, I have a question.
You have a question. All right, what's your question?
Where are you getting the fractions? Like, where does 7/12 come from?
Okay, do you notice the 7 check marks I have on the screen?
Yeah.
It's identifying the 7 numbers that are greater than 5 in my list. So those are the 7 things I want. The 12 is all the possible outcomes that could happen.
Okay, and then you got the 0.58 for repeating from 7 divided by 12.
Correct. And then the percentage, you can just take your decimal and times it by 100.
Okay.
Likelihood, Izzy.
Likely.
This is a likely event. Okay. And then we've got the last one. I know. We want the probability of rolling a number greater than 12. What if it what? Did you just ask if it lands on a corner?
I mean, it's technically possible.
Anderson? Okay. Must know if it lands on a corner, it's going to fall on one side. All right. How many of these numbers are greater than 12? It's a fabulous question. Fisher? So the probability of a number greater than 12, Fisher says, is 0. That would be correct. That likelihood is considered impossible. Very good. Sophie. Yes. Eloise.
How do you get the number that's greater than? Like, how do you get 5, 12, or 11? Like, you know, the numbers in the parentheses.
It's the question that's being asked on the screen. I wrote it in symbols because that is a lot of the way it's going to be written in your problems.
Okay.
And I just want you familiar with the different formats you're going to be seeing. Okay. Probability. Can probability be greater than 1? No.
No, it can't.
Probability cannot be greater than 1. So can probability be a mixed number? No, it cannot be a mixed number. Can it be an improper fraction?
Yes. No, it cannot.
It cannot be. I mean, does it make sense that 7 out of 5?
That's more than 1.
Yeah, that just doesn't really make statistical sense. We're not talking about the Kansas City games, okay? Yeah, we all know those are rigged. Can probability be negative? No. Probability is specifically between 0 and 1. Impossible to certain. It's very rigid as to where it can lie. Okay? What is 50-50? That's equally likely. Is equally likely the same as being fair? Not necessarily. Tell me something that is fair, but not equally likely. It's fair, but it is not equally likely. Anderson, give me an example. No, I picked the name wheel. That's fair. It's just not equally likely. Cameron? Yeah, rolling your die. It's fair if it's a standard 1 through 6 or 1 through 12, but not equally likely. All right. This spinner on the bottom of the page, is it fair?
Yes.
This one?
Yes.
The red and blue one.
Because there's 10. Wait, no.
No, because there's 4 and 5.
The gray is.
There's more blue than red.
Okay, so we see that each slice of it is equal, but the color distribution is not equal. How could we make it completely fair? Fisher?
If we made all the colors the same.
Okay, we could make it all the same color. Then it would actually be a certain wheel. How could we make one change on here and have it a fair?
Oh, make that gray spot red.
Yeah, we'll make the gray spot red. And now it's fair. It's also what else? It's also equally likely. It's back to that 50-50. Good. Here's what your assignment is. Pages 510 through 512 in the book. Actually, I think it's 4 through 18, not 5 through 18. I could be wrong. The answers get submitted into the computer by tomorrow at 11:59 p.m.
The answers to this?
Yes. Okay. I did screenshot pictures into Edge Elastic. So if you leave your book in your dad's car and you're trying to do your math, you should be able to do it off the computer
Wait, so these need to be done Thursday night?
by tomorrow night. All right.
Put these on the computer?
Yeah. So you can work book and computer at the same time for the remainder of class. All right. And those who have not been in class because you were making up tests, I'm going to start uploading this, and I should have it linked on Canvas probably within the next 30 minutes. You can listen to the argument about, rocks floating in water. Great argument. Oi.